Design a gear pump for a discharge of 50 lpm at a delivery pressure of 30 bar. This is the frequently asked question in Mumbai University examination for 15 to 20 marks, may be asked in question number 4 and question number 5. So basic parameters we have to find out for a design of a gear pump, that is selection of a motor, design of a shaft, design of a bearing, casing, bolts, suction and a delivery pipe. In question, discharge and pressure is given, but discharge is given in lpm, pressure is given in bar, so we need to convert it into Newton per meter square for a pressure and for a discharge meter cube per second. So pressure is 30 bar, 30 into 10 raised to 5 Newton per meter square, Q equals to 50 lpm, 50 into 10 raised to minus 3.60, we get the value of discharge in meter cube per second. So first step is we have to draw a sketch of gear pump, and the second one is the selection of a electric motor. As we know the basic formula, P equals to rho QGH, take a rho GH at one side and P and Q, P into Q. So put the values of P and Q, we get the basic power, P equals to 2.5 kilowatt. Then to find the motor power, the basic formula is shaft power equals to, or motor power equals to P upon basic power upon mechanical efficiency into hydraulic efficiency. Put the value of P, that is basic power, that is 2.5, and the mechanical efficiency is 0.9 and hydraulic efficiency is 0.95, that is standard values. So we get the values of shaft power or motor power, that is 2.92 kilowatt. Take the standard value of power from PSG 5.124. So in PSG we get the value of basic motor power is 2.92. So as a 2.2, the next value is 3.7. Always take the next value, that is 3.7. From PSG 5.124, we select the motor of 3.7 kilowatt. For a 3.7 kilowatt, there are 3 speeds are given in RPM, that is 1000, 3000 and 1500. So as we know the 4% is tolerance, so multiply it 1000 into 0.96, we get the value of first speed, that is 960. Then since Q equals to 50 lpm, that is less than 100 lpm, if Q is less than in 100 lpm, always select lowest speed, that is 960 rpm. So this is the selection of motor. Now next one is the design of a gear. So for design of a gear, we need to write 2 to 3 parameters related to gear, which type of gear is, then which type of profile, pressure angle, cutting, casing, type of gearing, then select a gear material. To select gear material, always select alloy steel from PSG 8.5. The values are given. Alloy steel, we select 40 Ni to Cr1, molybdenum 28. For this, sigma B is 4000 and sigma C is 11,000. So these values are in kgm, so we need to convert it into Newton per mm square. So always remove the 10 from the value of sigma B and sigma C, we get the value of sigma B and sigma C in Newton per mm square. Now we have to calculate Q theoretical. As we have value of Q actual, now Q theoretical equals to Q actual upon volumetric efficiency. So volumetric efficiency is 0.95, that is standard value. We get the value of Q theoretical. Then next is the Q theoretical equals to 2 pi into B into M square into Z into N. Okay, so for this we need to calculate value of M. So we need to find out module basically. So for psi m equals to b upon m equals to 7, why we take a value of b by m equals to 7? Because for GP psi m equals to 6 to 8, so we take a value of 7. So put all values in this formula. Q theoretical equals to 2 into pi into, as a b equals to, this m will shift to the side of 7, so b equals to 7m. So b is 7m into m square. As we know, the z value is 17 into n is the m60, so we get the value of m 4.18. so selecting the next number, selecting a model equals to 5 from PHE 8.2 preferred series table number 1. Okay, so this is the page number 8.2 preferred series table number 1. 4 point basic model value is 4.18, so we select the value. Next value is 5. Okay, so resubstituting we get the value of 5, m equals to 5. So put this 5 into this basic formula. So Q theoretical equals to 2 pi into b into, put the value of m in meter, into 17 into 960 upon 60, we get the value of b. So for checking psi m, our b value is 20.5 divided by m is 5, so 20 by 5 is 20.5 divided by 5, so the value is 4.1. but our b by m value is 7, or in between 6 to 8, so psi m is fail. So we hence reducing the model at 4. So take a value of module is 4. So again put the values in basic formula. Q theoretical equals to 2 into pi into 7m into m square into 17 into 960, so we get the value of b. Psi m equals to b by m, b value is 32, m value is 4, psi m equals to 8. So the next is y equals to pi in bracket 0.154 minus 0.912 upon z1. This formula is given in PHE 8.50. As we use involute tooth profile, so this formula is given. Rewrite this formula, put the value of z1, that is 17, we get the value of y. Next one is fs. So for fs, sigma b into m into b into y. So put the value of sigma b, model is 4, b is 32, y is 0.3152, we get the value of fs. Okay, so next one is Cv equals to 3 plus Vm upon 3. This formula is also in PHE 8.51. Cv, as we use commercially cut fills, so Cv equals to 3 plus Vm upon 3. Okay, so for to calculate Vm equals to pi dn upon 60. Now we have to find the value of diameter. D equals to m into z. D equals to, module is 4, z is 17, we get the values of d, convert it into mm, convert it into meter, so we get the value of Vm. Now put the value of Vm into Cv, we also get the value of Cv. Now this next one is the P equals to Ft into Vm. We have to find out Ft, so go to PHE 8.50, Ft equals to Hp into 75 upon Vm. So basically it means P into Vm. So P equals to Ft into Vm, put the value of P, standard motor selection motor power 3.7 into 10 raised to 3 equals to Ft into value of Vm. We get the value of Ft. Okay, so next one is the Ft. This formula is also in PSG 8.50. Fd equals to Ft into Cv. We have value of Ft and also Cv. So put the values, we get the value of Fd. Always Fd is less than Fs, then the design is safe. The next one is checking for a wear load. For a wear load, we need to find out Fw. This formula is also in PSG 8.51. This is the formula for Fw, d1 into q into k into b. So for finding out k, this formula also available in PSG. K equals to sigma c square into sine alpha 1 upon e1 upon plus 1 upon e2 upon 1.4. For q, 2 into I upon I plus 1. For external, we always use external gear for a gear pump design, so I plus 1. Now put the values. We have a d1, we have a q, k and b. We get the value of Fw. Fw is always greater than the Fd, so design is a safe. So next design is design of a bearing. In design of a bearing, we need to calculate horizontal component, vertical component, then resultant load, then equivalent load, life of bearing, dynamic capacity. So for a horizontal component, that is Fhx, this is the standard formula. Fhx equals to minus 1.64 into Pmax into Ra into B. Okay, so Pmax equals to P into service factor. So P is pressure is 30 into 10 raised to 5 into service factor is 1.2. We get the value of Pmax. Then to find out Ra equals to dA by 2. And to calculate dA, the formula is available in PSG 8.22. That is the tip diameter. Okay, so dA. So dA equals to Z1 plus 2 into FO into M. FO is 1 in special case and FO is 0.8 for a stub tooth. So here in special cases we take a value 1. So Z is the Z value is 17 plus 2 into FO is 1, model is 4. We get the value of dA. So Ra equals to dA by 2, we get the value of Ra. So put all the values in this standard formula, we get the value of Fhx. Now we need to find out vertical component of a hydraulic load, that is Fhy. We have value of Ft, that is tangential load. Now for a radial load, Fr equals to Ft into tan alpha. Put the value of Ft and tan alpha, that is alpha is 20 degree. We get the value of Fr. Now resultant load on a bearing, that is Fr, F capital R, that in root Fhx square plus Fhr square plus Ft square plus Fr square. So put the value of Fhx square, Fhr square always 0, then Ft square, Fr square. We get the value of F capital R. Then select a needle roller bearing. We select needle roller bearing. For that, equivalent load x into, this is the basic formula, x into v into Fr plus y into Fa into service factor. So x is 1, v is 1, Fr by 2. So as we know, so in this diagram the main load is in center and the two ends are fixed, that is Fr by 2, Fr by 2. So Fr by 2 plus y is 0, so y into Fa is 0, service factor is 1.2. We get the value of EE, that is equivalent load. Now so the life of bearing is LH equals to 8000 hours. Assuming we assume the value of LH equals to 8000 hours, so by 10% reducing life, L90 equals to 60 into LH into N, that is 8060 into N60, 960 upon 10 raised to 6 in million revolution. We get the value of N90. Now find out the dynamic capacity, the value of C. Basic formula, L90 equals to C upon P raised to K. K means 10 by 3. This formula is available in PSG 4.2 or 4.5. So put the value of L90. C upon value of P is then 10 by 3, we get the value of C. Now we selecting the needle roller bearing from PSG 4.5, take a suitable C. So C value is 2746.81. So select 2800 standard dynamic capacity, that is in kgf. Okay, so next step is design of a shaft. Since the gears are integral type, that is shaft and gear is single component, material is same as a gear, that is 40 Ni2 Cr1 molybdenum 28, sigma b equals to 400 Newton per meter square. Shaft is subjected to bending only. So we need to draw this diagram, that is the value of B is 32. So for this we need to calculate M max. Formula is Fr by 2, this Fr by 2 into B by 2, this width is B by 2 plus this 17 by 3 minus Fr by 2 into this B by 4. Okay, put all the values, we get the value of M max. Now we calculate TEQ. For that T is required, so P equals to 2 pi nt by 60. As we know, the total power transmitted is 3.7. Power transmitted to each gear is 3.7 by 2 equals to 1.85 kilowatt. So 1.85 into 10 raised to 3 equals to 2 into pi into value of n is n960 up into T upon 60. So we get the value of T in Newton meter, convert it into Newton mm. Next is TEQ. In root, T square plus mx square equals to pi by 16 into d cube into tau. So put all the values and calculate tau. Now for shaft we always select C45. For C45 tau permissible is 45. As we calculate tau is 33.72 and tau permissible is 45. So always tau is less than tau permissible, then the shaft is safe in torsional failure. Okay, next one is design of a casing. Select material for casing is GCI 25 from PSG. For a GCI 25 equals to sigma ut is 250, that is given in 1.4 page number, taking FOS 9. This is the assumable factor of safety. So for to calculate sigma t equals to sigma ut upon FOS, we get the value of sigma t. Now to find the thickness of casing, so for thickness of casing the formula is given in PSG at 6.15. So for a thickness of casing, this formula we have to use. So T upon R1 equals to in bracket 1 plus P1 upon sigma divided by 1 minus P1 upon sigma raised to 1 by 2 minus 1. Okay, so calculate P1 or Pi value, that is P into service factor. So P is 30 into 10 raised to 5 into 1.2, we get the value of Pi 3.6 into 10 raised to 6. Convert it into Newton per mm, that is 3.6. Put the value. T R1 is 38, that is T upon R1 d1 by 2, then 1 plus Pi value 3.6 upon sigma t value to 27.77, we get the value of thickness of casing. Okay, the next one is the design of a bolts. For design of a bolts, Ft equals to P into projected areas of a casing. So projected areas are shown in this figure, that is this is TA, this is A. So this area 1, this is the area 2, and this is the area 3. So A1 equals to pi by 4 into dA square by 2. Area 2 equals to A into dA. A1 and A3 is equal. So Ft equals to P value is 3.6, area projected areas 5 by 4 dA square, this one, and A into dA. We get the value of Ft. Now assume the number of bolts of a equal size, that is 8, selecting C50 as a material of a bolt, and assume the factor of safety 3. So as we know, we select the material from PSG 1.9 for a bolt or a shaft, that is C50. So for a C50, the value of sigma YT is 38 in kgm. So convert it into Newton. So it's 380. Value of sigma YT is 380. FO is 3. We get the value of sigma T. Now to calculate DC square, core diameter of a bolt, sigma T equals to FT upon N, number of bolt, into pi by 4 into DC square. Put all the values to calculate DC. We get the value of DC. Now DC equals to 0.84 into DO. DO is outer diameter of a bolt. So this is the standard formula. Put the value of DC and calculate the DO, outer diameter of a bolt. And the size of bolt is M10. This is M10 means outer diameter of bolt into number of bolts is 8 bolts. Okay. Now last step is design of a suction and delivery pipe. Assume Vs equals to Vd, velocity is 2 meter per second. Then Q third, as we know, Q theoretical equals to As into Vs, that is area into velocity. So we have value of Q theoretical, As into 2, value of P is 2. We get the value of As, convert it into mm square. Now As equals to pi by 4 ds square. Value of As is 438 equals to pi by 4 and ds square. We get the value of ds, and ds equals to dd, means diameter of delivery pipe and diameter of suction pipe is equal. So it's a 23.61. Take a standard value 25.4, that is 1 inch.